Hello, students, and happy April to you, April 5th already. So let's get started. We'll have our do now. With our do now, we are going to start with, we have a little prompt about starting new projects. And since we're definitely into spring, I thought it would be fun to just talk about what it is to start something new. Our objective, this will be, I believe, our last day to review exponents. You've been working really hard with those, and I'm really proud of you. So our essential question will be, how do the exponent rules work together when we evaluate expressions? So we're really putting it all together now. Our assignment will be to complete the do now, complete the work page, complete the exit ticket, and remember, show me your work. If you don't get to finish, you can finish it for homework, but show me what you've gotten done in class, okay? Most people get done in class, but I know sometimes you don't. We are now starting the fourth quarter. This is the fourth quarter. Yeah, third quarter is basically, as far as assignments, is over. Now we're in the fourth quarter. So we'll get to our exit ticket in a couple of minutes. But remember, if you finish early, we've got a nice little mindful art and mindful game activities for you to do. And you can find those clickable links in Class Notebook in Teams. So here's our do now. April is a good month to begin a new project. What is a project you'd like to start? Do you want to learn something, make something, or be something? People think of starting new things in January, starting a diet or get in shape or, clean my room or straighten my closets and drawers out or whatever. But, spring comes and the air is fresh and there's a newness in the air. So it's not just September and January that we start new things, but let's hear what you've got planned. Maybe you haven't even thought about starting something new, but spring's a great time to do that. So I'd love to see your thoughts. So here we are in April. So we'll get back to this page in a minute. Here's the mindful arts activity. It's a mandala maker. And then we have a sliding puzzle. I know those were such a hit when I did them before. So we've got a Hello April sliding puzzle for you today if you finish early. So let's take a look at some of these monomials, polynomials, and how these exponents work together. So um, we're going to be using the product rule, it looks like. So we've got 6 times 6 times -2, which is -12. And on the A, we have -2 plus 11. Remember, when we multiply those exponential terms, we add the exponent. So that would be a to the ninth power. B, -1 plus -4 is going to be -5. And we do not like those negative exponents, so we will rewrite that with -12, A9 in the numerator, and B with a +5 in the denominator, and that's our final answer. So number 2, when we divide, we subtract exponents. So 12 minus 14, that would be 6 to the -2 power. Again, we're not going to leave that negative exponent. We will put it in the denominator. So that would be 6 to the second power, positive exponent, in the denominator. Now here we're simply subtracting exponents of like terms. So m7 minus 4 would be m to the third, and 16 minus 2 would be 14, and we're all set with that one. So number 19, 45p to the third divided by 5p to the -1. 45 divided by 5, we do the numbers first, and that's 9. And p, 3 minus a -1 is, remember, that's 3 minus -1, which is our not rule. So that would be 3 plus 1 equals 4. So that would be 9p to the fourth power. Number 20, 20 divided by -10 is -2. And 2, we're looking at the exponents now, minus a -10 again. That is our not rule. So that's 2 plus 10, which is I believe that's a -2. I'm sorry. That's a -2 minus 10. So -2 minus -10, which is -2 plus 10, which would equal 8. So that will be -2 to the 8th power. My photocopy is not very good here. I apologize for that. On number 21, 16 over 12. Both those numbers are divisible by 4, so that would be 4/3. And then we have our C, -6 minus -5, which is 6 plus 5, which would give us -1. And our D, -2 minus 2 is -4. So we definitely need to rewrite that. So our numerator can have our 4, but that's it. The 3c to the first power, and that becomes an invisible one. D to the fourth goes in our denominator. And that is our final answer for number 21. So number 22, we're looking at powers of monomials. When we raise a power to a power, we multiply the exponents. So 3 to the fourth raised to the fifth power would be 3, 4 times 5, which would equal 3 to the 20th power. And k, 3k to the third power raised to the 8th power would be k, 8 times 3 is 24. And w raised to the -2 power, then again raised to the 9th power, would be w to the -18th power, which we would rewrite as 1 over w to the 18th power. Number 29, 9w only is raised to the 7th power, and all of that as a quantity, 9w to the 7th power, is raised to the 2nd power. So first we do 9 to the 2nd power, w, 7 times 2 to the 14th power, and 9 to the 2nd power is 9 times 9, which is 81, and then we have our w to the 14th power, and that's our final answer. Again, with number 26, we have -2, a to the 3rd power, b to the 4th power. That entire quantity is raised to the 5th power. So first we have -2 to the 5th power. A, 3 times 5 is 15. B, 4 times 5 is 20. Now, -2 to the 5th power is -2 times -2 times -2 times -2 times -2, which is -32. Then we have that A, 15, B to the 20th power. And that is our final answer. Now, number 27, we have 4 being raised to the -3rd power. So that would be 4 to the -3rd power, then r, 2 times -3, -6, s, -1 times -3 would be a +3. So we have two negative exponents we need to deal with. So I want you to think of 4 times 4 times 4, which would equal 64. So we can think of 4 as the negative to the -3rd power as 1 over 64. Remember, we're making that exponent positive. So let me show you exactly, kind of not skip a step there and show you how I did it. So that would be 1 over 4 to the 3rd power, because we don't want the negative exponent. So 1 over 4 to the 3rd power is 1 over 4 times 4 times 4, which equals 1 over 64. Now, also in that denominator, we're going to have that r to the 6th power. And in the numerator, we can have that s to the third power. Now, because we actually have something in the numerator, we don't need that 1. That can become an invisible 1, and then that is our final answer. And that's this process we went through to get there. All right, so let's move on to a few more problems. We've got some mixed practice now, so we need to really pay attention to our order of operations, and let's put this together. So first we're going to work on the left side of this expression in number 28. So 15h16 divided by 5h to the fourth. 15 divided by 5 is 3. H to the 16th divided by h to the 14th, that would be h. 16 minus 4 is 12. And then we're multiplying that times the right side, which is 9h to the second. Now, 9 times 3 is 27. Then h, 12 plus 2, the product rule is 14. Number 29, we're going to have to work on the right side first because we need to raise this entire quantity of 6x to the fourth y to the ninth to the power of 2. So I will just rewrite the left side, and then I will start multiplying everything by 2 and raising 6 to the second power. So 6 to the second power is 6 times 6. That's 36. Then x, 4 times 2 is 8, and y, 9 times 2 is 18. Now, we look at this. This happens a lot. We have like terms. We can go ahead and subtract. 19 minus 36 is negative 17, and then we just write the rest of the expression, which is x to the 8th, y to the 18th power. And then number 30. First, we need to resolve this power to a power in the denominator. So I'm going to rewrite the numerator as is, 28p to the fifth, and then 2 to the third power is 2 times 2 times 2, which is 8. And then p, 4 times 3 is 12. So 28 divided by 8, let's change our color here so we can make this very clear. Now we divide 28 by 8. Well, both of those numbers are divisible by 4. 28 divided by 4 is 7. 8 divided by 4 is 2. And then we have p, 5 minus 12 is negative 7. Well, we are not going to leave that negative exponent. So p is going to have to go in the denominator. So our numerator is 7. Our denominator is 2p to the 7th power. And that's our final answer. So let's go on to number 31. We've got those M&Ms. Remember, we are going to multiply these first two terms before we do the addition. So we have 3 terms here. 1, 2, 3. So let's do this multiplication. Negative 6 times 2 is negative 12. And m, 5 plus 2 is 7. N, 2 plus 9 is 11. So I've just taken care of these first 2 expressions. Now I'm going to add to that 15m to the 7th n to the 11th n. It looks like I have like terms, which is great, so I can add them. Negative 12 plus 15 is 3, and then we have that m to the 7th, n to the 11th, and that's our final answer. Now, number 32, don't be afraid of fractions. We're going to raise this entire quantity to the power of 2. So 12 w to the 7th times 5, 6, w to the negative third. Let's work inside the parentheses first. 12 multiplied by 5, 6. So I'm going to work up here. If I have 12, I can put a 1 under that. I'm multiplying that by 5 over 6. Well, 6 divided by 6 is 1. 12 divided by 6 is 2. 2 times 5 is 10 over 1, which equals 10. So 12 times, I'm going to circle it, times 5 over 6 equals 10. Then we have, let's keep it in parentheses because we still have a little bit of work to do. W to the 7th times W to the negative 3rd, which would be W to the 4th. And all that is raised to the 2nd power. So 10 to the 2nd power is 10 times 10, which is 100. W, 4 times 2 is 8, and that is our final answer. So number 33, we have to divide both. Let's multiply the numerator before we divide by the denominator because we do have like terms here. So that would be negative 8 times 12 is 96. P to the 8th times P to the 6th. P, 8 plus 6 is 14. And then in the denominator, we have 16, P to the 3rd. Now, 16 goes into 96. That's a negative 96 6 times. So negative 96 divided by 16 is negative 6. P, 14 divided by P to the 3rd is P, 14 minus 3, 11. And there's our final answer. So let's look at number 34. Let's work with the right side of this expression first. So I'll just copy the left side, negative 7 r to the 4th, s to the 15th power, plus 20 divided by 4 is 5. Negative 2 minus a negative 6 is a positive 4. And s to the 16th minus s to the first power is s to the 15th power. And then we do end up with like terms. Negative 7 plus 5 is negative 2. And we have that r to the 4th, s to the 15th. Okay, number 35. With number 35, we're going to work with this denominator first. So we've got, in our numerator, we have 18, x to the 5th, y. In our denominator, 10 minus 2 is 8. And these are like terms, so we're okay with subtracting them. And it's x, y to the 2nd power. Now we can further simplify this by dividing both 18 and 8 by 2. So 18 divided by 2 is 9. 8 divided by 2 is 4. And x to the 5th minus divided by x to the 1st is x to the 4th. And y with invisible exponent of 1 divided by y to the 2nd power will be y to the negative 1st power. So we still have a little bit of work to do. In our numerator, we're okay with the 9 and the x to the 4th power. But in the denominator, we have our 4 and we have our y to the 1st power, and that can be an invisible 1. So we don't need to write it. And there's our final answer. And then finally, number 36, we need to raise this entire quantity 2c to the 5th, d to the 2nd, minus 5c to the 5th, d to the 2nd, to the 4th power. Well, we do have like terms here, so we can go ahead and subtract. 2 minus 5 is negative 3, c to the 5th, d to the 2nd. Now we're raising all of that to the 4th power. So first of all, our negative 3 to the 4th power is negative 3 times negative 3 times negative 3 times negative 3. Negative 3 times negative 3 is a positive 9. And then that times a negative 3 is a negative 27. And negative 27 times a negative 3 is a positive 81. And then on our C, 5 times 4 is 20. And on our D term, 2 times 4 is 8. And that is a final answer with that one. So let's go back to our exit ticket. Working with exponents isn't hard if you remember the exponent rules. So to add or subtract, you simply combine like terms. To multiply exponential terms, you add the exponents. To raise a power to a power, you multiply the exponents. To divide exponential terms, you subtract the exponents. Any exponent raised to a zero power equals any exponential term, raised to a zero power equals 1. So you've been working really hard. I'm super, super happy with how hard you've worked, with your dedication. And as a little reward, we do have those 2 fun activities at the end if you have a couple of extra minutes at the end of class or maybe later today if you want to look those up. So remember, keep working really hard at this because with practice, you'll be great.